Howdy! In this mini lecture, we will discuss fossil fuels as an energy source. Specifically, we will discuss coal, natural gas, and crude oil. The student learning objectives of this mini lecture are identify regions or nations with the largest reserves of coal, oil, and natural gas, identify which sector of the U.S. economy has the largest consumptive use of coal, oil, and natural gas, define EROI, explain its calculation, and utilize it to evaluate different energy sources. Identify the four main factors that influence the formation of fossil fuels. Describe how coal, oil, and natural gas are formed, and describe how coal, oil, and natural gas are harvested. We use energy in our homes, to power machinery, to drive vehicles, and to provide comfort and conveniences. For the most part, most countries rely heavily on crude oil, natural gas, and coal for their energy. These three energy sources are the three main types of fossil fuels. Fossil fuels are carbon-based fuels that are highly combustible. Fossil fuels are formed from the remains of ancient organisms buried underground and subjected to the forces of temperature, pressure, and time. You'll notice from this table that crude oil, natural gas, coal, and nuclear energy are all non-renewable, meaning these sources take millions of years to develop. Once we exhaust these resources, there will be no more of these types of energy sources available. The other types of energy sources that are used to a lesser degree include solar, wind, hydroelectric, biomass, geothermal, and tidal and wave energy. All of these energy sources are renewable. Renewable energy sources will be discussed in a separate mini lecture. Oil, coal, and natural gas supply 82% of the U.S. energy demand, so it's clear we are heavily dependent on a limited and non-renewable resource. As can be seen in the table at the top of this slide, some countries have more natural reserves of non-renewable fossil fuels. Some countries have substantial reserves of oil, coal, and natural gas, whereas others have very few. Half of the world's proven resources of crude oil lie in the Middle East, which is also rich in natural gas. Russia has the most natural gas, and the United States possesses more coal than any other country. Russia and China also have large coal reserves. You'll notice that Venezuela has the most oil reserves, followed by Saudi Arabia and then Canada. Look closely and you'll see an asterisk next to Canada and Venezuela in the oil category. This is because their oil reserves are from oil sands, which is harder to extract than crude oil. Saudi Arabia has the most crude oil compared to any other country. The figure on the bottom left shows the consumptive uses of coal, oil, and natural gas in the United States. Thicker bars represent larger amounts. From this figure, you can see we import a lot of oil and use that for transportation and to a lesser degree, industrial purposes. We import less natural gas and even less coal. The U.S. uses natural gas mostly for industrial processes and electricity generation, and to a lesser extent, commercial and residential uses. Coal is predominantly used for electricity generation. Recall the U.S. has more coal than any other nations. Notice that green bars at the bottom of this figure illustrate renewable energies. Considering that the bars are to scale and represent quantity, what does this figure tell you with regards to the role renewable energies play in the U.S. energy budget compared to conventional fossil fuel sources? The last thing I want to draw your attention to are the tan arrows to the right of the U.S. sector boxes that represent transportation, industrial, commercial, residential, and electricity generation. These tan arrows represent the energy that is lost or wasted. Imagine how we could reduce our energy demands if we could eliminate or minimize this lost energy. The graph on the right is the annual global consumption of fossil fuels. It should come as no surprise that fossil fuel consumption has increased drastically over the last 60 years. Though we once relied more on coal, oil has been the leading energy source for the globe since about 1965. What many people do not realize is that we cannot simply get energy for free. We must locate, extract, process, and deliver the energy we need. All of these things can be considered investment energy. It's important to understand the amount of energy that remains after the investment energy is accounted for. This amount of energy that is left over is called net energy, or the difference between energy returned, or in other words, the amount of energy you got out of the resource, and the energy invested in getting that energy out of the resource. Therefore, net energy equals the energy returned minus the energy invested. We can evaluate each energy source using a principle called energy returned on investment, or EROI. The EROI are ratios that are calculated by dividing the energy returned by the energy invested. In other words, EROI tells us how much energy we receive per unit of energy we put into the process. Higher EROI ratios mean we receive substantially more energy than we invest. Lower EROI ratios mean we receive less energy per unit of energy invested. For example, the EROI values for oil were very high in the 1920s, but they began to decline after that because as we extract more of the resource, there's less available to extract, and we therefore have to invest more energy to get that oil. In the 1920s, they could drill an oil well and oil would spontaneously shoot to the surface because of the high amount of pressure it was under. Well, we have extracted all of the easily accessible oil, so now we have to put more energy into getting oil out of the ground than we did in 1920. So you can see that EROIs can change over time. In the 1950s, U.S. oil EROI ratios were 30 to 1. Then in 1970, it dropped to 20 to 1. Today, the value is 11 to 1. EROI ratios can increase as technology improves. The callout in this graph in this slide illustrates that because the EROI increases after 1980 and again after 1990. These increases are attributed to advanced oil extraction techniques made possible by technology. Not surprisingly, industrialized nations use up to 100 times more energy per person than developing nations. This figure shows that wealthy industrialized nations typically consume more energy per person than less wealthy countries that have not yet industrialized. For example, the United States has only 4.4% of the world's population, but it consumes 19% of its energy. As was mentioned before, fossil fuels formed from ancient organic matter. Specifically, these fuels are formed from organisms that lived 100 to 500 million years ago. The energy in fossil fuels originally came from the sun, because the organisms that formed fossil fuels were ancient autotrophs. The carbon contained in these ancient primary producers became concentrated over time as the tissue of the organisms decomposed and were compressed. Most organisms go through aerobic decomposition after they die because they are exposed to air, bacteria, and other organisms that break down their bodies and tissues. However, fossil fuels were produced by ancient organisms that underwent anaerobic decomposition, which is decomposition that occurs when there is little to no oxygen. The fossil fuel produced depends on a number of conditions at the start of and throughout the process, specifically chemical composition of the organism, temperatures and pressures to which it's subjected, presence or absence of anaerobic decomposers, and passage of time. This figure provides an accelerated timeline to show how the three main types of fossil fuels develop. The first step in the process is that organisms such as woody vegetation, phytoplankton, or zooplankton fall into low oxygen environments such as lake, swamp, or shallow seas. The tree drifts to the bottom of the lake and is buried by sediment. The phytoplankton and zooplankton drift to seafloor and are buried. The organic matter from the tree, phytoplankton, and zooplankton undergo slow anaerobic decomposition and become buried deep under sediments. This is a process by which kerogen is formed. Kerogen is a complex mixture of hydrocarbons, which are compounds comprised of hydrogen and carbon. Kerogen serves as a source material for natural gas and crude oil, as well as some forms of coal. Heat and pressure transform kerogen to oil, natural gas, and some forms of coal. Notice that plant material, represented by a tree, is seen on the left side of this figure. This is because coal forms from plant matter that is compacted so tightly that there is little decomposition. On the right side, you see phytoplankton and zooplankton. These soft-bellied seed organisms eventually form natural gas or crude oil. In all cases, the ancient organisms must be subjected to geothermal heat and pressure to transform into fossil fuels. We will now examine each of these three main types of fossil fuels independently. Coal is the most abundant fossil fuel on Earth. Coal was created 300 to 400 million years ago in swampy environments. It is a hard, black substance formed from the compression of ancient woody vegetation. The amount of water and carbon content and the amount of potential energy varies between different coal deposits. This figure illustrates the various types of coal, how they were formed, their water content, and their potential energy. The first substance you see listed on the left is peat. Peat is organic material that is broken down anaerobically but is generally wet, close to the surface, and not well compressed. For these reasons, peat has far less energy than coal. However, if peat is subjected to additional pressure, heat, and time, it will turn into coal. Scientists classify coal into four different types: lignite, subbituminous, bituminous, and anthracite. Lignite has undergone the least amount of heat and pressure, so it consequently has more moisture and less energy compared to the other types of coal. Anthracite coal has undergone the greatest amount of pressure and heat, so it has a low amount of moisture and high condensed carbon content. This type of coal therefore has the most potential energy. If coal is near the surface, it is extracted using strip mining, which is when heavy machinery scrapes away massive amounts of land to reveal coal deposits. Subsurface mining is used to extract coal that is deeper underground. With subsurface mining, deep vertical shafts are dug and networks of horizontal tunnels are created through powerful blasting using explosives. A final way coal is extracted is mountaintop removal. We will discuss this method more in a different mini lecture. Crude oil, also known as petroleum or black gold, is a sludge-like liquid mixture of hundreds of different types of hydrocarbon molecules. Natural gas is a gas consisting mostly of methane, which is CH4. There are some other volatile hydrocarbons in natural gas. As a reminder, crude oil and natural gas formed when dead organic material were buried in marine sediments and were then transformed by time, heat, and pressure. The original organic matter was transformed into kerogen. Kerogen will form into natural gas or crude oil when acted upon by heat, pressure, and time. Natural gas is found at 1.9 miles below the surface, and crude oil is found at 1 to 2 below the surface. The map of the U.S. illustrates where in the nation natural gas deposits are located. Notice Texas is a prime location for gas production. Oil and natural gas are extracted by drilling holes deep into the ground to reach these deposits below. If oil is under pressure, it will rise to the surface through the drill hole naturally. However, if the pressure has been relieved, it will need to be pumped out. The oil that comes to the surface naturally is the easiest to capture. After we capture that, we have to work much harder to extract oil from the ground because the pressure is lost as oil is removed from the deposit. Note, it is a common misconception that dinosaurs formed the fossil fuels we use today. Most fossil fuels are from ancient woody plants, phytoplankton, and algae, so T-Rex is not in your gas tank. To test your knowledge on coal, answer the following question. Which form of coal has the least amount of energy? Is it peat, lignite, subbituminous, bituminous, or anthracite? The answer is lignite. Remember, peat is not coal. It does have less energy than coal, but it is not classified as coal. That concludes this mini lecture on coal, oil, and natural gas. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!